Hi, good day everyone. I'm Woei Jye. So today I would like to present on semiconductor manufacturing sustainability and the global business environment for stakeholder analysis. So firstly, the semiconductor manufacturing is a sustainability critical industry due to its enormous electricity and water consumption is highly GWP process gases that include NF3 and PFC. The industry trend analysis indicate that sustainability performance is increasing associated with technology roadmap, access to financing, and geopolitical resilience. The bibliometric mapping of the literature related to semiconductor sustainability prove that nowadays climate, energy efficiency, and material toxicity have become the central theme instead of marginal essential issue. So next, the key sustainability issue is that FAB is concerned with environmental management of process emission, water, and energy. Ultra pure water production is prone to trace pollutants, including urea and nutrient. Therefore, polishing and selective removal are needed to stabilize the resistivity to use and to reduce discharge. Most of the facilities' electric power in air handling to its cleanroom operation. In contrast, ventilation control and set point optimization are time efficiency inverses. Inspirational in terms of process design are greener chemistry and lower toxicity formulation. Semiconductor sustainability interplay between ecological, economy, and social system. PFAS and other long-term fluorinated chemicals in effluents increase the issue of toxic and precipitants, impose a strain on feds to seek alternative and enhanced treatment. The communities challenge high industrial withdrawal in circumstances with water scarcity, where corporate reuse and collective watershed scams are considered evidence of responsibility. Feds are also vulnerable to the volatility of electricity and the possibility of future carbon pricing since energy and HVAC intensive operations are also financial risk management strategies. Coming to next, I will talk about the stakeholder one, government. Governments inculcate sustainability expectation in expansion and subsidy models. Improving PFAS discharge limit and monitoring will resolve bioaccumulation and long-term toxic effect reported in semiconductor related water waste sorry is a wastewater. So long-term renewable power purchases and grid interconnection allow fab to reduce their scope 2 emission in the shortest possible time and cushion against cost increases and decreases in power costs. So next I will talk about local communities and employee. Credibility by local communities is based on the behavior of water and transparency. Publication of site level balances of water, establishment of a clear goal of reuse, as well as an investment into resilience at a basin level are indication that fab value share scarcity. CMP chemistries, H gases, and waste streams are also requested by employee and neighbor who have to have evidence of safe handling and therefore engineer exposure control and emergency preparedness are mandatory. PFAS and other fluorinated contaminant. Contaminants are a source of legitimate health concern in very sensitive watershed and high-density urban corridors, and grievance mechanism and voluntary disclosure would promote trust. Next, the stakeholder three will be NGO and civil society. So NGO and civil organizations need tangible performances rather than commitments. They promote phase down of PFAS and need to be proven to be able to reduce toxicity in effluent and sludge using alternative chemistry and advanced treatment instead of pushing the harm downstream. They also start to attack Scope 3, in which they insist that the semiconductor companies report supplier emission and hazardous input since upstream processes usually take up to the majority of the total footprint. Okay, right. Civil society associates such technical problem with public public health and ecosystem protection, mainly in areas where long-standing pollutants are already observed and demand communal air, soil, and water monitoring with an open publication. For the stakeholder for investor and business owner, sustainability is not a branding but an implementation activity for investor. They are looking forward to the projects which are going to be financially backed by abatement, HVAC optimization, water reuse because such upgrades usually break even in their operation and mitigate the carbon cost exposure. Great volatility and drop risk. Alright. So they also seek transparent and product specified LCS which quantify the impact of fabrication and downstream decrease of efficiency, especially in wide bandgap power electronic like GaN, which can decrease system losses. The possible target with the help of supplier report and third-party verifications are only low risk of greenwashing accusation, transparent, financing related to sustainability, and brand value preservation in sensitive foreign market. Alright, so for the business recommendation, to begin with, source low carbon electricity at long-term PPA, and at the same time, optimize the clean room to minimize scope 2 and cost with airflow, filtration, and set point optimization to minimize costs. Second, there should be a corresponding pair-tuned recipe when making claim based on the evidence of F-gas reduction as high destruction abatement and continuous emission monitoring should go through and hand in hand. Third, the reuse is going to be cascaded and some specified nutrients such as urea will be eliminated to stabilize UPW to maximize the U and accordingly reduce freshwater consumption. Fourth, redesign CMP to lower toxicity series and PET, as well as hasten the replacement of the toxicity unproven PFAS with other toxicity proven slurries and PET. So next, electricity use maximization of clean room ventilation, intelligent HVAC control, and process to minimize electricity use and peak demand tariff that create direct OPEX saving. Freshwater acquisition and discharge payment are boosted by water reuse and basin partnership. They are even able to balance out authorizing in water stress region by demonstrating joint partnership. So certified amendment and PFAS reduction decrease the regulatory risk and reputational risk in the market with high stake on the population well-being. So as a conclusion, The sustainability of semiconductor can become a practically task when done as a system involving governments, communities, workers, civil organizations, investors, as well as suppliers. The short-term pillars are also evident: decarbonize electricity and optimize clean room, ensure high efficiency of F-gases abatement, increase the cascading reuse and selective removal of nutrients in water, and ensure the replacement of hazardous chemistry such as PFAS in CMP and wet processes by less harmful one. The progress will have to be gauged, reported, unconditionally warranted, such as cover supplier scope 3 footprint to retain credibility, open capital, and defend long-term competitiveness. That's all for my presentation. Thank you.